Hello everybody. Today we'll talk about binomial coefficients, how to calculate them. Binomial coefficients, it allows us to do a quick expansion of x plus y power n. Okay? Why it's really important? Because it provides us a good context to present proofs, lot of things, example, especially sequences and others. Okay? Okay. We'll talk about combinations. Let n and r be positive integer number with r less than or equal to n, then combinational of n r equal combinational n minus r. Sorry for this question. Do you know what is the combinations? All of you got this?
Yes.
Okay, good. Or combination nr or r from n equal combinational n minus r from n. Okay, so we must prove this now. This equal this. Okay, combination nr equal combination n minus r. How? In this equation we have combination nr equal n factorial, it's a revision for you, n factorial over r factorial times n minus r factorial. So, and combination of n minus r will be the same, n factorial over n minus r factorial times n minus r. Okay? So, it will be equal n factorial over r n minus r factorial. So, will be equal to each other. We'll use this assumption, this equality, in how to calculate the coefficient of any polynomial series. Okay? We'll use this equation. CNR equals CN n minus r. We'll use this equation. Polynomial expansion. If we have this polynomial, x plus 3 power 3 will be equal x cubed plus 3x squared y plus 3xy squared plus y cubed. Okay? As you can see, the sum of coefficients of x and y must be always equal to 3. Example here, x cubed times y power 0. So y power 0. 0 plus 3 is 3. Here, 2 plus 1, 3. 1 plus 2, 3. y3, x0, 3. So when we expand any polynomial or any equation or any factors like this, the coefficient, the power will be always the sum of 2 power x and y must be equal to 3. Okay? Now we want to calculate the coefficient. Y here we have 1, 3, 3, 1 for each term. We have here 4 terms. What is the coefficient for each term? Okay. First, we will rephrase it as x plus 3 times x plus y times x plus 1 equal x times x times x, x cubed, plus, okay, plus x times y, give us x squared y, plus x times y times x, give us x squared y, and so on. X times y give us xy squared, y times x and so on to get this expression. Okay? Now, when choosing x twice, as you can see here, when choosing x twice and y once, like x squared y here, there are combination 3, 2 equal combination 3, 1 equal to 3. So the coefficient of x squared y will be 3. So from this equation, we have here x squared. X squared will give us combination, and the power is here 3. So x squared will give us combination 3, comma 2 for x, or combinational from 3, comma 1 from y. We have here y power 1, x power 2. So we can calculate the coefficient from x side and from y side. If we choose x, only x, or choose y. So one of them for x equal power 2, so combinational from 3 to x equal 2. Or the same, c from 3 combinational of coefficient of 1 will become always will equal to 3. So here we put the 3x squared 1. Okay? Did you understand this? The equation or the formula, the method tells us what is the power of x? What is the power of x? 2. Power of x is 2 from power 3, so combinational 3, 2. Okay? Power of y, 1, and the power is 3, so the combinational 3, comma 1. As you can see, they are both equal to 3 because we did it. Because we did it here, as you can see. Okay? We said before that C and R equal C and N minus R. Okay? We use this equation from this equation. Okay? Sorry, بس. Sorry. يصير معنا لحظة. Okay. Okay. Now we return here. So we look at the power. اتفضل شو عندك سؤال؟ اتفضل. شو سؤالك؟ حسين شو سؤالك؟ حسين شو سؤالك؟ Okay. I will repeat this. How we calculate the coefficient of any terms here? We look at the power of each index here. X squared, y. Let's take this example. X squared, y power 1. Okay? So, because we have x squared, or because we have y1, one of them it's enough. X squared, so the combination from 3, 2 from 3, give us a 3, so it's 3. Or from side 1, from y side, combination of y equal to 1, exponent of 1, 3 equal to 3. The same for xy squared. We can calculate this coefficient 3 from x power 1. From x power 1. Okay? So or y power 2, the same, will give us 3 the same. Another example, big example, okay, we'll do that. If you have this, x plus y power 5, how we know this 5, 10, 10, 5, and 1? So for each terms here, we'll take the combination of it for x. For example, for x, okay? To obtain x5, we have x multiplied by x 5 times. 5 times. Thus, of the 5 choices, we choose x 5 times. So, will be combination of 5 over 5, or 5 from 5 will be 1. Or we choose 0, 0 times. Here we have 0 power 0. Sorry, y power 0. Y power 0. So 0 times for y. So combination of 5 comma 0. The same. Will give us 1. Okay? Any question? Any question?
No.
No.
Okay. Now we calculate the other terms. Example here. x4 y, x4, x power 4 y. Okay. We calculate for x side will be, we choose x 4 times from 5 choices. So will be combination 5 comma 4 will be 5. Or we choose y 1 time, so the combination will be 5 comma 1 also will be equal to 1, to 5, sorry. So if you choose from x side, x power 4, so will be combinational 5, 4. If you choose y power 1, 5 comma y, the same answer will give us. Okay? Also, if we want to this x cube, y square, the same. X cube will give us c5 comma 3. Y square will give us c5 comma 2. The both give us the same number equal to 10. Okay? And so on. That's how we calculate all the coefficient for any polynomial. For any polynomial. Okay? Any question here? Okay. Now we'll talk about example here. X plus y power 5 give us this expansion, which is this. Combination of 5 from 5, 4 from 5 here, 3 from 5, 2 from 5, 1 from 5, okay, and 0 from 5, okay, from x side here, okay?
Vice versa صح؟
Sorry?
or vice versa إذا نعد من الواي سايد.
كمان فينا نعد من الواي بتكون 0 5 او 1 5 او 2 5 او 3 5 او هون لحظه هون 1 عم بعد هون 4 و 5 او 5 او 5 هي زيتا the same 5 5 او 5 0 the same number. We proved it before. Okay, so from x side or from y side the same. Okay. Okay. Now, what is the theorem? If you have x plus y power n, so the equation will be like this. From x side, n, y0. n minus 1, n, x, n minus 1, y1. Always the power of x and y must be equal to n. Okay? The sum of the power of x and y must be equal to n, always, okay? Here we have n plus 0, n minus 1, 1, n, and so on. And the combination will be from n, the exponent of each x here, okay? Or y. We can do it by y. Of course, we can do it by y. Okay? Or y. Here the same. This from x side. The first line is from x side. And the second line will be the same values from y side. So 0n, 1n, n minus 1n for y. To conclude that, the general equation will be summation j from 0 to n, combination j to n, xn minus j, yj. Okay? So this is sequence, summation of sequence. This is to calculate the coefficient of each term. Okay? Any question? Any question here?
No.
It's clear?
Yes.
Okay. Let's continue. Example. For you all, what is the coefficient of x power 12, y power 13 in polynomial x plus y power 25? What is the coefficient? Tells me.
25C 12
25C 13.
واحد 1 only. ارجع احكي.
25C 12
ايه كفي. بس هيك
تطلع.
هي ال 25C 13 هي الكوفيشنت.
ما انا حسبتها بس على اكس.
صح. اور على الواي فين نحسبها. اوكي؟ على الاكس هون فينا نحسبها على الاكس بس 25 لانه عندنا 25. اوكي؟ 12 from 25 على الاكس or 13 25 على الواي. The both will give us the same number. اوكي؟ بيطلع شوف الكوفيشنت ده بيطلع 5 million. Coefficient will be 5 million. Okay? Now, pay attention for this. What is the coefficient of the same term, x power 12, y power 13, n to x minus 3y power 25? Be careful. We have negative sign here. Be careful. How we solve it? Of course, it's not the same. Of course, it's not the same. Different value from above. Who tells me?
هلا هي حتكون alternating أول شيء. الباور is 25.
Okay.
فهيدي بتعطينا negative sign.
إيه بس شو الفاليو؟
الفاليو حيكون
مش هو ذاته انا بعرف.
لا. انتبه بالايكويشن فوق عندنا x بلس y تطلع معنا كومباينيشن. عندنا x بلس y هون عندنا 2x و 3y. even لو كان بلس عندنا 2x و 3y. 2x different from x. Okay? Focus on this. How we solve it? Different value. Of course, different value. Different value. Negative or positive, but different value. يلا think. Think. Any idea?
لازم نضرب باثنين شيء لان في 2x.
نضرب باثنين شيء في 2x يعني شوف كيف الحل. rephrase it. Okay? 2x plus minus 3 parentheses power 25. So we have here in this equation 2x is big X minus 3y is big Y. So from the previous example, previous equations here, this equation, okay, the coefficient will be summation j from 0 to n, jn x n minus j, y minus j. Okay? sorry, mute. في ناس عم تفوت، في ناس عم تفوت تظهر معنا اللينك. حدا منكم عاطي اللينك لحدا؟
خلينا
لا
نغير.
دكتور، يمكن يكون هو ذاته عم يفوت وعم يغير اسمه كل مرة.
في حدا عم يفوت هلا. طيب نكست سيشن حغير لكم اللينك.
دكتور اسمه احمد زهري او شيء هيك.
من الجامعه بتعرفوه؟
ما بعرف اذا من الجامعه.
بعتقد فيك اكونت، بعتقد حدا فايت بفيك اكونت وعم يغير. حدا من
بالضبط دكتور.
حدا من تلاميذ او شيء.
ماشي ماشي ماشي. Okay. Okay. So we use this equation to solve it. Okay. How? Look how. The new x here will be 2x. The new y will be minus 3y. Okay. We use the same equation before from j to 25. Big X power 25 minus j. Big Y equal power j. So big X will be 2x. Big Y will be minus 3y. So we convert it to plus because the equation we have is plus y. So plus minus 3y. Okay, we put here minus 3. Now for j equal 13, he will have y power 13. For j equal 13, we replace j by 13. We get this equation. It's negative, but a huge number. It's a huge number because we have 2x, 3y. Minus is alternate. One term plus, one term minus. Okay. But 2x minus 3y give us a huge number. So we
وكمان
solve
عم
it.
نضرب الاكس والواي.
صح، عم نضرب لانه تحولت. صار في عندنا اكس نيو اكس ونيو واي. صار في هاف نيو اكس ونيو واي. بيج اكس بيج واي 2 اكس سمول. اوكي فهمتوا الفكره؟ هون صار عندنا لانه عندنا 2 اكس از اكس minus 3 واي از واي، اختلف الفاليوز. صار في باور عم نضرب بباور 2 باور 12 3 باور 13 نيجاتيف. اوكي ديفرنت عن ساين. ساين مش مشكله، ساين مش هو المشكله. في يكون بلس ويبقى هو ذاته الرقم بلس. النيجاتيف منا problem. Problem is the coefficient of x and y. Give us a huge number. Okay? Using the same equation. But replacing x and y big X و big Y as you can see. Okay? Any question here? Any question? Good. Let's continue. Find the coefficient of x8, x5, y8, and x plus y power 13. Who tells me?
13C8 او 13C5.
Okay. Okay. 13C5 or 13C8 give us 1287. Okay? It's warm up question. Now, Pascal, solve this. Okay? Pascal, solve it. خلاص زعبت بده مني اكسبت جفت خلاص. Okay. Pascal said or notice that we have this. Okay. If we have zero polynomial يعني constant will be 1, coefficient will be 1, x, y equal x, y equal x, so 1, combinational from 0. If y equal 1 here, we have the combinational first term will be 0, 1, second term will be 1, 1. If you have two terms, n equal square, n square we have three terms. We have three terms, x squared plus 2 xy plus y. Okay? Okay. How to get it? From this triangle. Combination of the same equation. Combination 0, 2, 1, 2, 2, 2. Value 1, 2, 1. And so on, and so on, and so on. Give us a triangle here. But Pascal noted that each term, each coefficient will be dependent on the sum of previous line. Okay, so here we have combinational of 5 from 7 equal combinational of the same index 5 from 6 for line before plus the term before it. Okay, as you can notice, combination of 5 from 7 will be equal to combination for the same index 5, okay, but minus 1, and here will become n minus 1 plus the term before. Like here, 21 equal 6 plus 15. So the equation will be here, the equation will be for any position you want to calculate it, if you want, use triangle, n plus 1, k from n plus 1 will be equal k from n, the same k from n, plus k minus 1 from n. Okay, this is the general for equations Pascal said. To build up this triangle, we can solve it graphically if you want. Okay, or combinational c plus 1 k equal combination n k minus 1 plus c n k. Okay, okay, any question here?
No دكتور.
واضحه. اوكي، اكيد هلا فين نستعمل هيدي؟ فين نستعمل we can use this method or we can use the equation before, or we can use the equation before. Okay, okay. Algebraic proof of Pascal identity. This equation will give us n plus 1 factorial over k factorial and n plus 1 minus k factorial for each term, n factorial over k minus 1 factorial, parenthesis n minus this factorial, plus this. Okay, we substitute this. N plus 1 minus k factorial will be equal n plus 1 minus k times n minus k factorial. Okay, and n plus 1 factorial will be equal n plus 1 alone times n factorial. Also here n minus k plus 1 equal n minus k plus 1 هون في ناقصة factorial هون n minus k factorial. So we replace this. Okay, we replace it to get this equation. Okay, we replace n plus 1 minus k by this term and this by this term to conclude that we can divide it by n factorial, n factorial, n factorial. We remove n factorial. Also we remove k minus 1 factorial, k minus 1 factorial from here there, k minus 1 factorial from there. Of course, k bigger than 1. And n minus k factorial, n minus k, n minus k. To conclude to this, we make common denominator to calculate this and this and this. So it will be equal. Okay? From this calculation, the Pascal identity, it's true. It's true. Okay? We prove it by mathematical proof. Okay? Any question here?
لا تمام دكتور.
Now Pascal triangle said to us, focus here. Okay. He noticed that the sum of each row will be equal to power n. If we sum each row here, for n equal 4 example, if we sum it, will be equal 16 to power 4. For n equal 5, if we sum this with this coefficients, will give us 32 to power n. Okay? He noted that. Proof of that is summation of all combination from 0 to n equal to power n. We must prove this. Algebraic proof is very easy. 2 power n equal 1 plus 1 power n. It's easy. But 1 plus 1 power n is similar to x plus y power n. So we use this equation. Okay, this summation equation. Okay, we replace x by 1 and y by 1 to get the formula. 1 power k equal to 1, 1 power n minus k equal to 1. So the same. So from 1 plus 1 power n, we use the summation equation of coefficient and replace x by 1 and y by 1. 1 power anything will give us 1. So this is true. So this is true. So summation of any rows, summation for any rows, for n rows equal to power n. Okay? Okay. Now we have another thing. Also, Pascal noticed that the summation of even index equals summation of odd index. Example here. Here we have index 0, even index, equal to 1. Here we have index 1. Okay, the second term, index 1. So equal to 1, the same. Here, for n equal to, even index equal to 1, odd index equal to 2, even index equal to 1. So 0, 1, 2. Okay, so if we sum the sum of index values, 0 plus 1, index 0 plus index 2, sorry, the even index, if we sum it, 2 equal to. Okay, also even odd كاندكس. هون انتبهوا، الايفن والاود عم نحكي كاندكس مش كفاليو. اوكي، كاندكس عم نحكي نحن هون، عم نحكيها كاندكس. even index 1 and 3 0 2 even نعمل لهم سام بيطلعوا 4. هلا الاود اندكس 1 and 3 نجمعهم ويصمت تطلع 4. the same for all. Okay, so Pascal noticed that summation of even of index terms here equals summation of odd index. sorry هون في كلمة غلط. sorry مش odd. اوكي خلاص هنصلحها بعدها. Okay, proof summation from k to n minus 1k. Okay, kn equal to 0 must be equal to 0. Algebraic proof 0 equal to 0 n minus 1 plus 1 power n. هون حنستعمل summation of equation of coefficient. We use it as summation kn x power k j power j. Okay, hon. To conclude that, imply that the summation of combinational of even index will be equal to combination of the sum of combination of odd index. Okay, we have here odd index, we have here even index. Okay, so will be equal. Okay, any question?
كله تمام دكتور.
Okay,
Thank you.
any question? Okay, it's good. Okay, I will stop the record.